Welcome everybody, I'm Sakir Temel. Today I'm going to teach you the basics of home automation and how you can build your own web-controlled Christmas lights. A few words about me. I'm CTO of Visuality for 3 years. I prepared many different architectures for different parts of technology, and I architectured some IoT production-grade systems and created many IoT projects. Also created IoT and WRUG. I'm an IoT enthusiast. I think it's very delicious. It's internet connected for you. So a few words about IoT team. We built a couple of projects like Magic Mirror, Kitchen App, and Christmas lights. This is from our meeting. As you can see, it's after electroshock. It's our ritual. We are actually hobbyists, but also we are spending some time at work to work with IoT. We all have our own hobby projects. For example, Nadia has her motor and sensor included dress, which is also in the references link.
Could you put your microphone higher?
Yeah, sure. We have more people, but yeah. About today, we will have two objectives. So learn basic of home automation, and then we will analyze an application of the Internet of Lights focusing more on backend and architecture. This is out of scope. I'm not going to go into details, but feel free to ask those questions if you will have at the Q&A session for the out of scope part. I will be glad to answer. All right, so the first part is R&D web-controlled lights. We will have two parts. The first part will be interactive, so feel free to stop me, because I want each of you to understand what's really going on to be able to continue the second part. So we need to do R&D for our web control lights, because we didn't know exactly what is that about, and we need to see the risks and answer a couple of questions. That's why doing it in R&D way was the best option. So you remember this from schools. So this is the first school project. You have a battery, you have a switch, you have a light bulb, and you close the circuit, the light bulb is on. So that's my inspiration when I was creating this web-controlled Christmas lights idea. So we will see how it is going to evolve for us. There won't be a lot of text. I actually brought all the materials that you need. We can build one, but I also have some cables. So let's assume that this is the battery from our project. And this is the switch, and you have the light bulb. When you press the switch, you have your light bulb on. How it is connected to our web-controlled Christmas lights? Yeah, if you will just sit next to this and look at the screen and do manual operations, you will be able to have web-controlled Christmas lights. So as you can see, the switch is making a problem for us because it is manual, and that is the first problem that we need to solve. So then, what we have done, the first thing, we replace this switch with a relay. So important thing is like we replace that. So it does exactly the same thing what the switch is doing, closing the circuit or breaking the circuit. We have two cables for it to do this. I'm going to explain why it is for. I also have relay in here. Those are like very cheap and nice things. So the first thing of home automation that you need to know how the relays work. They're magical, but they're so simple and nice. So when you give 5 volts to the coil, you're actually creating an electromagnetic field that is pulling this metal, and then this is actually closing the circuit. So what is the problem that this motor or light bulb wasn't running is that the circuit wasn't closed, and when this metal is pulled, you're actually having another, like the circuit, current to go from here, and then you have your circuit closed. And this is like a real circuit, the real relay that you're seeing. So that is something that I have. This is a relay circuit. It's not relay. You have 2 relays, as you can see. The relay itself is these blue ones. And when you look at home automation articles, you will see this like most of the time. So what we do basically is that this part is C, this part is NC, and when you give 5 volts to here, you're basically connecting C and NC, which is closing the circuit. Any questions? Is it clear for everyone? That's great. So when you are actually closing this metal, you're also hearing a click sound. Do you know where else you're hearing this click sound?
When you switch the light?
Excuse me?
When you switch the light?
Yeah, that is the manual operation one. At the cars, when you want to give a signal to left or right, you see. So that's actually coming from there, because the two metals are, or from the elevators and so on. So yeah, that is how the relays work. So what we have done, again, let's come back to our circuit. We replaced our manual switch and we made it electronic. So what we need to do is give 5 volt from here and the ground from here. That's great, and thanks to that the circuit will be closed and the light bulb will be on. What is next? We made it electronic and now we need to make it more programmable. So how to programmatically give 5 volts? First of all, if we are talking about some programs, we need to execute it, that's why we need a computer. And what I'm doing here is like I put a computer here, which is Wi-Fi connected here and I'm powering it with USB power. It has some ports and programmatically I'm able to give 5 volts to here to close the circuit. Okay? And how I am doing this is the computer. I'm using particle photon, but you all know this device, I think, Arduino. So I didn't use Arduino, but this particle photon, it has Wi-Fi inside and it's $20 and you will see why I love that. So let's look at the particle. So this is the schema of particle. And as you can see, you have pins in here, digital pins and the analog pins. Let's say I'm using the D3 pin, and I would like to give 5 volts from the D3 pin programmatically. So what I do is I'm just defining D3. As you can see, this is like all on the web. And then at the setup part, I'm saying that this port is going to be used for output. And at the loop, I'm saying give 5 volts, which is actually 1. So we have zeros and ones in computer. Let's give 1, so 5 volt, until this computer will be off. While I'm getting from D0, D1, 0 volts, I'm getting 5 volt thanks to this programmatic thing. Thanks to this idea, you can do a lot of things now. Any questions?
Is that C++? What language?
Well, this is actually an Arduino code. It is C++, but I think they also made some changes, but it's mainly C++.
Basically, the linker is special. It concatenates all your files. You don't have to write any header files for it. It's all encapsulated in those two functions.
Yeah, so like when you're writing Arduino code, you're also seeing that some things are simplified from C++, and they have the same type of idea in here. And what is awesome in here with this particle, you don't need to connect even USB to program that. So what you do, you just go to build particle I/O, because you defined your device to connect to this, and you just say flash. So that's awesome. So you can program online your devices. And it looks like this. It's $19, it's actually $20. All right, so what we have done, in the very beginning, the things were manual, and we made the things electronic and then programmatic. When the code of ours run, we basically give 5 volts from here, which is creating an electromagnetic field in here that closes the circuit, and the light bulb is on. And then the rest, what you can do is up to your imagination. What I have done, a loop. You hear the click sound? So it's just like a for loop going from the first one to the last one. That was an 8 module relay. The one that we have here is 2 module relays. And it was connected to particle photon, to all the pins, all the digital pins. Do you have any questions so far? So yeah, we talked about relays and they're connected to lights, but in reality, what we eventually have with the things that we learned so far, yeah, don't watch it too much because like, you know, doing that was like not so easy. All right, so far You now know how to control your lights via internet. That is nice. You can do it programmatically, but it's still difficult. What we need is an interface, an actually public interface for letting others to control and for you to easily control that. So what I do is, so this is me or someone else. It's basically HTML JavaScript page, and I have a button on, and I'm sending a request to my backend, and my backend is sending a signal to my particle to close the circuit. Right? So
is this backend Lambda?
Could be.
no, of course Rails. This is Ruby user group, but of course can be, and it will be a good idea actually to have Lambda in there. All right. So the question is how we can really send this signal to this device. One another reason to allow particle, what you do is you just say that this function of mine should be exposed with an API as bulb endpoint. And then from your backend, what you can do, just caroling your device ID, your access token, and the parameter. So from your backend, when you do this operation, it's like a basic HTTP post. You are actually calling this function and sending on as a command, which is giving 5 volts to the D3 pin. Magical? Clear?
How do you know your device ID? Is that something that they give you?
Yeah. Actually, it's somewhere here. You have the token and the device ID. They have another panel that you can also see, like what's going on in the device, like all the logs, like when it was online and so on. So there are more reasons to allow a particle. That's the main motto of today's presentation. So we added a web page and we send a HTTP post, and I said that we should allow particle. Okay, that's mine. Okay, so that's the checkpoint, controlling the devices via an interface. So thanks to the knowledge that you just now learned, or you knew but you repeated, you can control your bulbs, your lights, your fridges, or your anything via web. So you made a lamp which is web controlled. So it has evolved from this circuit to this one. Any questions? I will be glad if you will have. So, because the second part will be just using this information that we have.
I've got one question.
Sure.
So we have this particle. You can connect as many as you have open pins there. I mean, how many lights you can connect to this?
So in simple way, you can connect 8 lamps.
Okay.
I mean, like you can control 8 of them directly. But when you have LED strip, for example, like you have 200 lights, you're still able to control that. The things that are happening there, I think, like some signal modulation and so on. So it's a little bit more magical. So you can control as many lights as much. But if you want to do it simple, you can easily connect 8 lamps in here.
Okay.
So you need another mechanism that will translate the complex messages into lights if you want to control more.
And you need to select a pin and just turn it on.
Exactly. So like either give 5 volts or 0 volts.
Yes.
What you can also do with these pins, you can also read like if it is 5 volt or 0 volt coming from sensors, for example. Any other question? So, okay, we know the basics. Right now, you know how to toggle a light bulb via web. The title of our presentation is how to build your own web-connected Christmas lights, right? You build an interface here, and you have a button that you can turn on and turn off the lights, but it would be so weird if you just give some default messages that, okay, your light is on. So you need to show people that actually light is on. And how to do this? Wait. With the information you can have this. I always forget about this slide. So when someone is recording you, that's okay. But how to connect end users to see what is really going on. You need to stream what is actually really going on with your Christmas light, right? So you need to do streaming. And I found YouTube when I was looking at all the alternatives. It's free, easy, reliable, embeddable, so on and so forth. In the beginning, for our R&D work or for our project, it was the most difficult and challenging part because we didn't know a lot of things in here. That's why I love this project, because we learned a lot. And we also needed to connect IP camera. You're going to see what I'm talking about in a second. So, yeah, you just have a camera here. So that is watching the light. And you have a Linux server with FFmpeg that is getting the input from the camera and sending it to YouTube. And in your web page, you're just embedding a YouTube video. Simple. Questions?
So we basically now used 5 computers to power a single light, right?
Let me see. Yeah, more or less.
Plus the entire YouTube infrastructure.
That's how the world is working nowadays. And we run probably 10 Lambda functions already. So we have like how we are streaming the input from camera to YouTube. That's interesting, and that was challenging. It wasn't that easy. It is scary, but it is, you know, when you understand what's really going on, it's less scary, but still scary. So you're saying that to FFmpeg, it's really magical and nice tool, like it does everything. My input is the IP camera with the RTSP protocol, and this is the codec and so on, and my output is basically YouTube. And then you're running this in your Linux server, and then you're adding a supervisor to that, just for it not to fail, or if it fails, it should just refresh itself. And then you have your video streamed on YouTube. That's good. Okay, camera part is also handled, but what are the other ways that switch and backend can communicate? So the way that we are doing is using particle service, calling functions via HTTP requests, which is nice. One way is like, you know, sending comments direct to the device because it's a computer. But the problem is you need to have some ports open at your office that you really don't want to, and set up a lot of things. Device may check if there is a new message every 1 second, so it's like pulling all the time. That's also an idea. But the best is like chatting. So why actually I am analyzing this question in R&D? Because it was needed for the project. We have some animations. I'm going to talk about it in a second. So it will be good for animations, so continuous conversation. It will have a history, it will have queuing, we will be able to see the online status of the devices. We don't need to reconnect as we are doing with HTTP requests. And some errors are handled by the chat services. So what does it mean really, like chatting? You know this application probably. So it would be so nice, for example, if you had a channel, the light bulb, and the backend and switch can communicate to each other. So backend is basically delivering that I received such a request and you should turn on the lights. And then the switch is saying, all right. And it would be so fun to watch what they're talking about. It is fun. Actually, we did it once, like we connected two devices to Slack. And it was fun to watch them. That's nice, but using Slack will be a little bit an overkill because, okay, this computer is nice, but the RAM of it and the resources that it has is quite limited. Therefore, we are not going to use Slack, but we will apply the same concept because what we are really interested in is chatting, not Slack. There we use MQTT. I just learned that it is message queue telemetry transport today, and I copied it from MQTT.something. It's a machine-to-machine connectivity protocol. It is lightweight. It has a small code footprint, and it helps when you have network bandwidth as a problematic thing. Okay, yeah.
So it's like HTTP, but for machines?
No, it is TCP for machines, you can say. It is two-way. And it is lightweight. I'm not sure if it is running over the TCP or it's something like TCP. I was all the time thinking that it is actually replacing TCP. But yeah, the main benefit in here is it has small code footprint, and it can run basically anywhere. So like you have a lot of libraries. Any more questions about MQTT? So this is Ruby user group, so I have some Ruby code here. How you can connect to this, to backend and the Particle. So you just require MQTT library, and then you give your server's URL, and you say, if I receive a command on, just publish to the lightbulb channel on message. And in Particle end, what you do is just define MQTT client and connect with a nickname and subscribe to lightbulb channel. Whenever you receive something from the lightbulb channel, just do some operations. Clear? And what is really nice and magical in here again, in Particle and in Ruby, I easily could find really nice libraries for that. So that's why MQTT is quite nice. And for IoT, like if you hear IoT, you will for sure hear MQTT. Any questions about that? All right, so we have done the R&D. Boring part is ended. So let's do our project. Let's do some real work, right? What we are going to do in here, we are going to repeat what we have learned at the first part, and the things that we learned at the first part, or the answers that we get at the first part, will be input for this project. Okay, the initial idea from 2016 was live webcam stream with buttons which will let people to turn on and off lights, so someone from somewhere can share the Christmas spirit online. So that's the project description. Some basic features, so there should be web-controlled lights, people should be able to send animations, there should be a landing page welcoming them. But what is more important here for me is the non-functional requirements. Okay, you build a web page. As a tech provider, you're creating a unique solution to share with your partners and followers. And if it breaks, you will be really ashamed. That's why you needed to extra focus for it not to break. So I didn't want to have a fragile solution in here. And we needed to have near real-time feeling. Otherwise, people will be bored and will say that nothing is working. But actually, the things were really working, but they wouldn't be seeing it. And it should be fault tolerant. I didn't want to be awake 24 hours if something goes wrong. So the system should fix also itself, and it should be also fault tolerant. And it should be done until Christmas time in 2016. I think the idea was there, I mean, it was in idea stage in October, so until that time. All right. So now we can pass. That is the architecture that we have for our Christmas lights. You're going to have it in a second now. Because I'm going to explain each part again, and it will be easier to follow also from there. I really like creating IoT architectures because you have the system feeling and you're able to apply the things that you learned in computer science. So like some computer organization, microprocessors, or some computer science additional knowledge. That's why it's like my most beloved architectures when I'm doing it. So let's begin. First thing is first. What you need to have? Lights. So we had actually 8 lights. Some of them also changed. And they're all connected to here, somewhere under the building. And you all have manual switches for them. When you have the lights that you can operate manually, what would be the next step? Switch, to make it electronic. So this is what we have done. As you can see our photon here. Oh, it's not so easy to see, but this is our 8 module relay. And this is something industrial power source. So it's to give power for the particle. And again, it should be reliable, you know, also here. And then the lights and so on. Okay, what is next? You need to make an interface to be able to control these lights. What we have done is like, because it was in feature requirements, we said like, let's not only make turn on and off, but let people to make some animations in there. So we build an animation builder. As you can see, each column is actually representing a second, and each row is a light. So as you can, like here, at the 5th second, 6 light will be on. So you're building your own animation. Sky's the limit. You can just send anything. And after you have like your frames and of your animation, you're just saying ready and send. So we have the interface as well. What's next? We need to have a camera to show what is really going on. We have this Delink camera. I love that. It looks like a robot. It also can pan and zoom, so this is like turning around. So it's so nice to play with that. It has also Wi-Fi inside, so that was also good for us. And another thing is like it's from Delink, so again, it helps for my non-functional requirements, which is reliability. So it's an IP camera at our office. So when you have your IP camera, you need to have server to get the input from the IP camera and stream it to YouTube. It's connected to our routers, as you can see. So this is running basic Ubuntu and sending the video to YouTube. All right, and it has some supervisory inside, so the process is handled with the supervisor if something fails. Do you remember the near real-time feeling? You put an iPad. This is actually from this iteration. Yeah, it has a heater in here because in Poland iPad can freeze. And so the camera is looking to the garden, but first it is saying the iPad. We are going to see like why it will be important for our non-functional requirement in a second again. And the iPad was mainly for dealing with the delay and the queue stuffs. So we talked enough about the devices, and our friend doesn't like using a lot of hardware. I think it's waste. So enough devices, let's talk about what is really going on the cloud side. So you know that we have this web application, and it is connected to YouTube, so it's embedding from to there. We have a Node.js server. I mean, it was like 100 lines of code, so I didn't want to use something else. Which is getting the requests, animation requests, to here and directly inserting it to Postgres database. And there is a background worker which is listening what is added into the database and sending it via MQTT. When you send let's do it in a practical way. When you send an animation to be played, this is the only table that we have in our database. So you have your name, message, IP address. We also record when it is sent and the duration. And here it's important, like you have 6 instructions, 6 frames, so 6 seconds. And you see some decimal numbers in here. We are going to see what they are. We talked about this MQTT worker. I named it like that. It's a background worker. It handles the queue of animations and MQTT communication. I wanted to split this, web part and the background part. It works 2 ways. It knows when animation is started and finished, so that's also good. It treats the PostgreSQL database as a FIFO queue with running some SQL commands. What is also nice that I really love it. It's like my assistant. It auto-recovers the system if something is stuck. So normally I would do it manually. So that is also nice. A big part, the code in particle is like how we are handling the frame. You remember the decimals in the database? So basically they are 32 bits integers, and they are decimal representation of the instruction that I have. So I created an instruction set for that. For example, if you have last 8 bits like this, first and the third light will be on. That is the idea. What I also do here is I use a ring buffer. I found this as the most right approach for that, because you have a limit in there and you need to free up space in the particle when the animation is run. So it's easy to use and control. So that's the code in the particle. So our solution now implemented. We touched each part except the recording server part, but it's basically when animation is running, it uses another FFmpeg package just to record that animation so that we could send those animations to the people who send these animations. So we didn't use like anything extra than the first part, and our solution is implemented. And after you complete your project, what would you do next?
Run it.
Yes, or test it. Yeah, run it, launch it. Okay, it's important to create some IoT things, engineering products, but if no one is using it, I mean, if you're creating a system, users are your actors and they are also part of the system. That's why you need to do some marketing. So we created some newsletter and social media posts. We launched it December 20. It is battle tested. We received many wishes and we had lots of joys and positive feedback. So our followers or our current clients or the previous clients had this email. And what was happening when they click on that, they simply go to this page where they can create their animation. Let's do it. Yeah. Okay, for a second, let's make everything dark. And then let's turn all of them on. And they should say ready. They can write their name. Let's write maybe WRUG 2020, right? Yep. 8. And let's send this animation. Important thing in here is look at the time in here. What is it? 58. So this is our iPad. I'm glad that it worked. All right, I put the references links in here. Thank you very much for listening to me. Follow me on Twitter. Ask any questions whenever you want about anything related to IoT or any other things. Now, Q&A session.
I have a question about programming. You said it was 32-bit integer. You have 8 lights.
Yes.
Technically, 8 bits would suffice, but you had some fancy duration control. Can you talk a little bit more about that?
Of course. Actually, you're talking about this.
Yeah.
In this instruction set, I have 3 instructions. The first one is starting with 0001. That says that animation starts. So the last of the bits I'm using for the animation ID. And the other one is 0002. It's for animation ended. And here I have also duration, because in the very beginning I wanted to make it not only work for like 1 second, but even faster. But then I needed to slow this down because of streaming, that people won't be able to see the things so fast. And those extra 20 bits is actually connected to our friend's question. When I want to connect more lights, I didn't want to implement everything, but just use these extra bits. So it's something from microprocessors that you sometimes have these additional bits for future usage. So that was the idea.
So each frame is actually duration controlled, right? That's the whole point.
Yeah, exactly. So you can, initially I was thinking maybe let's make it like half a second, because it's more fun. But when you're building the animation builder, it wasn't that easy. It was really challenging to build animation builder. Nadia did a great job in there. So.
Any more questions? Thank you.
Thank you very much.